Yo, what's up, guys? Welcome to another lesson of Algebra 1. Continuing chapter 11, we're going to go to section 2, lesson 2. This time we're going to be talking about multiplying and dividing rational expressions. Real quick recap for you guys. A rational expression is a ratio of polynomials. Okay? And we're going to be learning how to multiply and divide them. Some of these examples are going to be straight up easy, yo. And some of these things are going to take a little bit more thought, but nothing to be worried about. We're going to go ahead and try to make this as easy to understand as possible. So let's go ahead and look at problem number 1. Let's just jump right in it. Alright, problem number 1 is asking what is the product? And if you guys remember, a product is an example of a multiplication problem. So we're just going to go ahead and multiply these two things. So my suggestion, the first thing you should always try to see when you guys are trying to multiply is you ask, can anything cross cancel? Alright, if it can cross cancel, it's going to make our life a lot easier. Alright, so I'm going to look at this example. Can anything cross cancel between 6 and a cubed? Nope. A squared and negative 2? Nope. So all we're going to do is, because they're fractions, you're just going to multiply across the top. You're going to get 6 times negative 2 is negative 12, divided by a squared times a cubed is a to the 5th, and that is your answer. That wasn't that bad, right? Very logical. The answer for this one will be negative 12 over a to the 5th power. They do ask you to state any exclusions. So what values is a not allowed to equal? Well, in this case, looking at our denominator, a is not allowed to equal to 0, because if a did equal 0, this whole thing would be 0 in the denominator, and that's a no-no. So real easy, really easy. All you do is multiply. You check to see if you can cross cancel, multiply across the top, and state the excluded values. Now let's look at this next one. And I'm going to tell you why I like this lesson, because this lesson leaves things, I wouldn't say unsimplified, but they leave them in factored form. And that's a very valuable time saver for us. So first thing I'm going to do, can anything cross cancel? Can x minus 7 cross cancel with x plus 3? Nope. What about x and x minus 5? Nope. In order for these to cross cancel, they have to be the same exact term. So this just gives us x minus 7 times x minus 5 over x times x plus 3. And guess what? That's our answer. We don't even need to, well, I guess step 1 would be cross cancel. Step 2 would be multiply. Okay. We don't even need to factor or FOIL these out. We just leave them like this. We want to leave them in what we call factored form, and this is factored form. The last thing is state any excluded values. All right, I'm looking at my denominator, and x is not allowed to equal two different values. It's not allowed to equal 0, because if 0 went right here, the whole thing would be 0. And x is not allowed to equal to negative 3, because if negative 3 was plugged in right there, the whole thing would be 0. And we're not allowed to have a 0 in our denominator. So this would be our answer. And if they ask you to state any excluded values, those would be our excluded values. All right, so let's go ahead and look at got it question number 1. Can anything cross cancel? 5 and y cubed? Nope. 3 and y? Nope. So we're just going to multiply across the top. 5 times 3 is 15. And y times y to the 3rd is y to the 4th. You just add the exponents. And that would be our answer. And y is not allowed to equal to 0. Cool. Next one, can anything cross cancel? X and x minus 3? Nope. X plus 1 and x minus 2, none of those are the same. So our answer is just going to be x times x plus 1, leave it in factored form, times, or divided by x minus 2 times x minus 3. Leave it in factored form. There are two exclusions. X is not allowed to equal 2. If I set this denominator equal to 0, x would not be allowed to equal to 2. and x would not be allowed to equal to 3. All right, so this would be our answer, and these guys would be our exclusions. Cool. Problem 2 uses a similar concept of cross-canceling, but kicks it up a notch. Looking at this example, it says, what is the product of this monstrosity? Well, this monstrosity would be made much less monstrous if we factored it out. If Shia LaBeouf helped us out with this one and we tried to factor out each term individually. So for problems like this, we're going to try to factor completely. All right, and then we're going to try to cross cancel. Now notice this one doesn't say anything about finding the excluded values. They just want you to factor and then cross cancel. So taking each individual term, x plus 5, I kind of covered that up. That was not good. Did it again. X plus 5 cannot get any lower, so we're going to leave it as x plus 5. Let's do a different color. What about 7x minus 21? Actually, those both have a GCF of 7. So 7 goes in the front, and I would have x minus 3 left over. Times, can 14x go any lower? Nope. 14x stays the same, and we'll do one more color, this guy. Now this is a regular factoring problem where I'm trying to find factors of negative 10 that add to 3. All right, and if I think about my factors of negative 10, that would be 1 and 10, 2 and 5, and since they multiply to negative 10 and add to positive 3, I'm going to say this is x minus 2 and x plus 5. Now I ask myself, okay, so I factor completely, and can anything cross cancel? Well, yeah. It looks like x plus 5 and x plus 5 can cross cancel, and also 7 and 14 can cross cancel. Often forgot that we can cross cancel just regular numbers. This would become a 1 and a 2. And what do I have left over after all of that? Well, I would have 2x on the top. Here's a 2. Here's an x. And I would have x minus 3 and x minus 2 on the bottom. And that would be our answer. They don't say anything about finding the excluded values, although we could see that there are easy excluded values. There'd be 3 of them, it looks like. 1, 2, and 3. But they don't say that, so this would be our answer. So we're going to factor completely, then cross cancel. Let's go ahead and look at this example over here. Forgot it, question 2. 3x squared, can that go any lower? Nope. 3x squared. X plus 2, can that go any lower? Nope. X plus 2. This can be factored as regular factoring, where I need factors of 2 that add to 3, and that would be x plus 1 and x plus 2. And x, can anything cross cancel? Yeah, it looks like x plus 2 and x plus 2, and this x and one of these x's. So my final answer would be 3x times x plus 1, and that's it, divided by 1. Problem 3 tries to look fancier than what it actually is. They're asking, what is the product of, let's go ahead and write it out. Change the color. I like this color. All right. 2m plus 5 over 3m minus 6 times m squared plus m minus 6. This looks fancy, but all you do is put this over 1, and now you just do the same thing we just did as the last example. You factor out completely. Are there any GCFs for this top numerator? Nope. So 2m plus 5. All right. Are there any GCFs for this denominator? Yeah, they can both be divided by 3. So I have 3. And then left over, I would have m minus 2. And over here, I would have regular factoring. I need factors of negative 6 that add to 1. and that would give us m and m. That would be a 2 and a 3, negative 2, positive 3. Can anything cross cancel? Yep, it looks like m minus 2 and m minus 2. And left over we'd have 2m plus 5 times m plus 3 over 3, because 3 times 1 is 3. There's nothing else that can cross cancel, so that would be our answer. Now so far all of the problems we've done have dealt with multiplication, but what if they ask us to divide? Well, healthy reminder for us, that dividing by a fraction is the same thing as multiplying by its reciprocal, or reciprocal, or reciprocal. So if I am given this example where they ask us to divide, what I can do is I can simply rewrite this as a multiplication problem, where I keep the first I keep, change, and then flip, where I keep the first fraction the same, x squared minus 25 over 4x plus 28. Then I change this division sign to multiplication, and then I flip the back fraction. This becomes x squared plus 9x plus 14 divided by x minus 5. Now this just becomes just like all of the other ones where we have to factor out completely. Looking at this guy right here, this is a difference of squares, and difference of squares factor out to conjugate pairs. So this would be x plus 5, x minus 5 over, this would have a GCF of 4. So 4x plus 7 times, and then this would factor out as regular factors of 14 that add to 9 would be 2 and 7. So x plus 2, x plus 7, and x minus 5 can't go any lower. Can anything cross cancel? It looks like x plus 4 and x plus 4 can cross cancel. X minus 5 and x minus 5 can cross cancel. And that appears to be it. So I'm left with x plus 5, x plus 2 over 4, because everything else reduces to 1s. Cool! Alright, problem 5 wasn't even that big of a deal. It's the same thing divided by a polynomial. You would just make this into a fraction by dividing it by 1, and then you multiply by the reciprocal. So that's not even that big of a deal. We can go on to the next example. Now this is what I'm talking about. Now this looks scary, and quite simply looks a little dumb, because this is a fraction within a fraction. And we're going to call this a complex fraction. Whenever you have a fraction within a fraction you don't really know what to do, we're going to call this a complex fraction. But just a reminder that a fraction is just the same thing as division. And we just learned a rule that would help us work with division. So instead of writing it like this, I'm going to write it as 1 over x minus 2 divided by x plus 3, so we're 3, over x squared minus 4. And because this is a division, we can keep, change, flip. Keep, change, flip. We can keep the first fraction the same, 1 over x minus 2, change the division sign to multiplication, and we can find the reciprocal or the reciprocal or the reciprocal of x plus 3 over x squared minus 4, and we have x squared minus 4 over x plus 3. Now the good news is when I try to factor this guy out completely, most of it stays the same. 1 over x minus 2 can't change, but on the top we have a difference of squares. Difference of squares makes conjugate pairs, and I would have x plus 2, x minus 2 over x plus 3. Can anything cross cancel? Yeah, and I get x plus 2 over x plus 3 as my final reduced answer. Well, there you have it. A lot of work to do. Go do it.